Okay, so I would like us to take more examples and solving with our first principle. Now, let's see a particular question like this. I think I have this one in my book. Okay, let's take number 3 question. And we have 2x squared plus x plus 2. Let's try to solve this question. 2x squared plus x plus 2. Now, we know that therefore our y is equal to what? 2x squared plus x plus 2, right? Then if you add a change in y, it will be y plus delta y is equal to what? 2 bracket for this. Anyway, you see x, you put it as what? X plus delta x carrying raised power 2 plus what again? This x also become what? X plus delta x plus 2. Then what do we have here? We have y plus delta y. Let's continue with this, opening this up. When you expand this, we have what? 2 bracket x squared plus x, that will be 2x delta x, and then we also have what? We have plus delta x squared. Then plus, here will just be x plus delta x plus 2. And then for y plus delta y, we have it as what? When you open this with your 2, you have 2x squared plus 4x delta x plus what? 2 bracket delta x squared. And then plus, here is x plus delta x plus 2. So we can add up like terms. 2x squared can add up, okay? 2x squared can add up anything, but we can, well, there aren't any like terms here, so. Okay, so I was thinking I'll find a like term, but there is no like term here. So I just continue with my solving since there are no like terms. So let's call this one equation what? 2. And this is our equation what? 1. Therefore, I can then do what? Subtract 2 from, so let me write it out, 2. Let's say subtract 2 minus 1. And that'll be what? Y plus delta y minus y is equal to everything here. That's 2x squared plus 4x delta x plus 2 delta x squared plus x plus delta x plus 2. Wow, this is a very long work. And then minus, we have what? Put it in brackets, 2x squared plus x plus 2. I know my face is blocking that side, so let me just move my screen up a bit. Okay, so we have this going up. Now let's continue our solving. So we have y minus y. We know that it peters out, cancels out. So here will be what? Just delta y is equal to what? So we have 2x squared. Now, let's open this bracket here, and then we have it as what? 2x squared plus 4x delta x plus 2 delta x squared plus, that's going to be x plus delta x plus 2 minus 2x squared minus x minus 2. So we can cancel out like terms. So this cancels out this, right? What again can we see that cancels out? X cancels out x minus x, and minus 2 also goes out with this. And so what is left? We have just delta y is equal to what? 4x delta x plus 2 bracket delta x squared plus delta x, and that's it. Now what's the next thing we do? We divide through by what? Changing x. So whatever I do, you also do the same thing here. Now, since we're dividing through by this, we can see that what happens, that this can cancel, sorry, let me change that to red. This can cancel this can cancel this, and this can cancel this. If you wanted, you would have broken them into separate fractions, and then you still see that it will still be the same thing that happens here. So this particular one can cancel out a 1 delta x from all of these, and therefore we have our delta y delta x as equal to what? 4x plus 2, just 1 delta x plus what? 1. Here is now plus 1 because it cancels out as remaining 1. Now what's the next thing we do? We apply our limits. So let's apply our limits. We have that dy, let me use a different color now since I'm entering into that part. So we have that our dy dx is equal to the limits as delta x tends to 0 of delta y delta x, and that is equal to what? For 4x plus 2 delta x plus 1. So when we take the limit as this delta x tends to 0, what happens? Anywhere we see delta x, what do we put as 0? So that's like writing what? 4x plus 2 multiplying what? 0 plus 1. And that's equal to 4x. 2 times 0 is 0 plus 1. And this is your dy dx. And that's the final answer. Okay, let's take more questions. Let's try to solve just as much as we can solve, just to explain this topic more and more. So let me shift my screen this way, and then okay, so I can split it. And let's take another question again. If our y is equal to 1 over 2x plus 1, let's solve this one. For y equal to 1 over 2x plus 1. Now, this is also our equation 1, right? Yeah. And then we can take our y plus change in y is equal to what? You add, anyway, you see your x, you put it as what? 2 bracket what? X plus change in x plus 1. And let's call this our, let's open this first before we call it our equation. Y plus change in y is equal to 1 over 2x plus 2 delta x plus 1. And then let's call this our equation 2. Now what do we do again? It is equation 2 minus equation 1, right? So that will be what? We have this as y plus change in y minus y is equal to what? 1 over 2x plus 2 grad x plus 1 minus 1 over 2x plus 1. Now, you see here that we can find the LCM of these two. Is that not so? Yeah, we can find the LCM of these two. But first of all, let's cancel out the ones that can cancel out this, can cancel out this. And so we have that y plus, sorry, that's just delta y now. Delta y is equal to, now find the LCM of these two. The LCM will just be this multiplying this. So that will be, oh, that's not sweet. That's 2x plus 2 delta x plus 1 brackets 2x plus 1. And then what do we have here? You just interchange it. That's just the trick here. But okay, let's just do the local way. Everything here dividing this will give you just this. Multiply by 1 is 2x plus 1 minus everything here dividing this will give you this. Multiply by 1 will give you what? 2x. Now, since it's minusing it out, I want to just open it to the minus sign straight away. So minus 2x minus 2 grad x minus 1. I use this minus to open out the value when I multiply. So let me take my screen also this way, and then let's continue solving. Sorry. So, that's a mistake. So I wanted to take the screen this way. But push it a bit here, and then cancel this line. So, sorry, I just want to adjust the screen so that I can also see where I stopped at and know where to continue from. Okay, so here we have what? Delta y is equal to, now we can see that some values can cancel out here, right? This can cancel out this. Is that not so? So what do we have? And then let's also open this one as well under. So we have this as what? 1 minus 2 delta x. I'm seeing this minus sign here. Is this supposed to be a minus something? Yeah, okay, it's supposed to be a minus 1, right? Yeah, minus 1. Oh, so that's that. Even the 1 also cancels out this minus 1 here. Oh, sorry, I didn't put in that one. So therefore, even our 1 here is also out. So our 1 here is out. In fact, what we only have here is minus 2 delta x. So let's put that in. So we have minus 2 delta x over what? Opening this one, what do we have? We have 4x squared. Remember, let's use this one to open this one. 4x squared. And then we have plus, this is going to be a very, very long opening. Plus, but let's continue. 4x squared plus, you know what, let's take it step by step so that we won't rush it too fast. So taking it step by step, I have that 2x is opening 2x plus 2 delta x plus 1, then plus 1 also opening what? 2x plus 2 delta x plus 1. Okay, so this just so we'll do it step by step. 2 delta x over what? Now opening this, we have 4x squared plus 4x delta x plus what again? We have 2x plus what's the next part here? We have what? 2x again plus 2 delta x. You just repeat it entirely. So now let's take like terms. Like terms, we are like terms. We know that these two can add up each other. That's the only thing that can add up entirely, right? That's one of the funniest aspect. So 2 delta x over here is what? 4x squared plus 4x delta x, and then we have plus 4 plus 4x plus 2 delta x plus 1, and this is for changing y. Now the next part is to now bringing your delta, changing that's divided by changing x also. So changing y over your, let me just use a different color. For changing x is equal to, we have minus 2 changing x over, now we're having your changing x coming in, changing x also, bracketing everything here, and then that's what we have it as your 4x squared plus 4x bracket changing x plus 4x plus 2 changing x plus 1. So notice something here. This 1 will straight away cancel out this one, so it's already out. And let me take my screen up. So we have that changing y over changing x is equal to, we have this as minus 2 over that is, here is just 4x squared, still repeating everything. Oh, that's too long. Changing x plus 4x plus 2 changing x plus 1. Now what's the next thing we do again? We apply limits, right? So we apply limits now. So that's bringing out dy dx. So we can say that dy, let me use a different color again for that. So let's bring in our dy dx. We can say that dy dx is equal to the limits as changing x tends to 0, and then that will be what of what? Changing y changing x, which is equal to minus 2 over 4x squared plus 4x changing x plus 4x plus 2 changing x plus 1. Wow, that's a long walk. Okay, and then it's equal to, when we take as this tends to 0, so everyone that tends to 0 you just cancel out. So this one will become what? A particular 0, and 0 multiplying 4x is still 0. This one becomes a particular 0, and 2 multiplying changing x is still what? 0. So therefore we know that our dy dx, which is equal to our limits as changing x tends to 0 of changing y changing x, is equal to minus 2 over what? 4x squared plus 4x plus what? 4, okay, plus, that's for this 4x plus what? 1. So let me put it plus 1, because this one entirely goes out, this one entirely goes out. So we have 4x squared plus 4x plus 1, and that's basically how we solve it. So I want to just check out, is there anything like if you look at this, you can see that this can also be written with one bracket. You can write this, you can factorize this as what? As minus 2 over this 2x plus 1 square. Look at it, it's actually 2x plus 1 square. So minus 2 over this is your dy dx. So therefore, if they ask you what is the derivative of this, where do we say from? Okay, we say from here. If they ask you what's the derivative of this particular value, you just get what? Minus 2, and then you add this part. So this is the answer. This is all that we've done. Now this is first principle. First principle is kind of very long. Don't worry, but when we enter into the second principle of solving, as we're working with the laws, all those, your chain rule, your product rule, and the rest of it, it is going to look very, very simple. But it's good to understand the first principle, because many times in your exam questions, they usually ask you to solve with the first principle, just to test you to know who can do it, because they know that most students don't like first principle. That's the truth about it. So you know what, let's take one more question, and then we'll enter into the second principle. Let's just take one more extensive question, then we'll enter into the second principle of solving differential equations. Okay, so I'm looking for where's an empty space now.